Okay, guys, now I'm going to be solving your homework number 2. That is going to be still angles. It's going to be really easy, so do not worry. In the first problem, they are asking us to be converting degrees, minutes, and seconds to decimal degrees. In this case, they're giving us 27 degrees, 4 minutes, and 51 seconds. If we can have the same values as if we were working with the clocks with hours, minutes, and seconds, we have 1 degree is equal to 60 minutes. 1 minute is equal to 60 seconds. How the equivalent is to be doing this, we need to be dividing all of this so we can have the values. For example, we start having how many seconds here? 51. 51 seconds. How many minutes are there? We know that the value is 60 seconds is equal to 1 minute. Mhm. So by rule of 3, remember, we multiply in a cross, we multiply this and we divide these parts. So 1 times 51 and that all over 60 is going to give us how much? 0.85. 0.85 minutes. So now the value is going to be 27 degrees 4.85 minutes. Now we're going to be transforming the 4.85 to degrees. Remember, 1 degree equals 60 minutes. It's again the same value, the same rule of 3. How many degrees are 4.85 minutes? We know that 1 degree equals 60 minutes. Again, a rule of 3. This is going to be multiplying this part and we're going to be dividing over this one. So it is going to be 1 degree times 4.85 over 60, and this is going to give us how many degrees? It gives us 1.8008. That is the value. If we add that to our value that we know that is 27, it's going to be 27.0808 degrees. But remember, they're asking us here to be rounding our answer to the nearest thousand. Nearest thousand, remember, this is a tenth, 100, and 1,000. meaning we need to be rounding this value to have only 3. Remember, 1,000 is 3 decimals. So the correct answer is going to be how much rounding this? That's correct. 27.08. We put this one, this goes up, so it transforms this one, this becomes a 1, 81 degrees. As you can see, this is our correct answer, 27.018. Okay, now we go to the next one. They're asking now the same thing, but in the to the inverse, to the opposite. Now they're asking to be converting all of this, that is a decimal, to degree, minutes, and seconds form. If necessary, we need to round our answer to the nearest second. So this one, to the nearest seconds. So to the nearest whole value. We begin. How? We divide. We already have the degrees. We have 149 degrees. We're going to be putting the 0.175 degrees to the test. In this case, remember, 1 degree equals 60 seconds. And no, my mistake. 1 degree equals 60 minutes and 1 minute equals 60 degrees. So we need to transform all the values of this one to from degrees to seconds. So we just multiply the first place. The part that is missing or we have in decimal values, we need to multiply times the nearest the thing that we need to convert. In this case it's minutes. So it is going to be 1.75 times 60 in order to have minutes. So in the first part we have 10.5 minutes. So if we continue this part, we already have the minutes part. So we could be writing this as 149 degrees, 10 minutes, but we are still missing the second part, the second. So the decimal parts, we're going to be multiplying times 60 again in order to have the seconds. So the missing part is 0.5 times 60. In this case, it's going to give us seconds. 0.5 times 60 is going to give us 30 seconds. That's why we put the 30 seconds here. As you can see, this is our answer. 149 degrees, 10 minutes, and 30 seconds. Now, the next one. We are going to be transforming degrees to radians. You need to have this value in mind that pi radians is equal to 180 degrees. This is the value that you need to be always aware of. Why? Because this is an equivalence. This is a correct equation that always is going to be true. So to be transforming and to have the equivalence of 1 radian, we need to get rid of this pi, right? So in order to get rid of this pi, we're going to be putting to the other side dividing. So we have one equivalence, 1 radian equals 180 degrees over pi. Again, we can do the same thing. We can be multiplying this part because it can be 1 times 180, and we need to get rid of this 180 in order to have only the value of 1 degree. So 1 degree is going to be pi radians over 180. So we have the value. In this case, we have 390 degrees. I'm going to be writing this here in yellow, 390 degrees. They're asking how much radians. Now we can put this in a rule of 3. Remember, we already have this value. We know that 180 degrees over pi equals to 1 radian. Now, what do? We need to multiply and to divide. Okay? The multiplication is going to be 1 radian times 390 degrees. All of that is going to be over 180 degrees over pi. How much is this? I can put that, all of that in my scientific calculator. That's why you need your calculator. 1 times 380 over 180 over pi. Guys, I'm sorry again. I made a little mistake here with why they were asking for us to be solving for. Again, I apologize to you all. We can reset this thing. Now, again, we can begin again. They're asking to be transforming 180 degrees to, we don't know how many, radians. But we have the value of 1 degree. We have that 1 degree already is equal to pi radian over 180 degrees. That is what you need to be doing. Remember, we do not have, we know the equivalence of 1 degree to radians. And we need to know the value of, in this case, this much, 390 degrees in order to find how many radians, because we know that 1 degree is equal to pi radian over 180. Now we do our multiplication and our division. It's going to be 390 degrees times pi radian over 180 degrees. If we solve this, we put the whole value in our scientific calculator, is going to be yes, that is a correct answer. In this case, it's going to be 13 over 6 pi radian. This is going to be the value. As you can see, this is the value that is going to be the correct answer. How do we know this is 13 over 6? We can put the whole thing as 390 degrees times the multiplication of 1 over 180 degrees. No, times pi. And we can do first this division. 390 is going to be divided by this part, and then it's going to be multiplying times the value of pi. 390 degrees over 180 degrees is going to be 13 over 6, and then we multiply that times pi. That's how we get to the value of this one, 13/6 of pi radians. So this is solved. Now we're going to do a similar thing, but now it is to the opposite. Because we're converting radians, sorry, radians to degrees. Again, the value. One radian is equal to 180 degrees over pi, and 1 degree is equal to pi radian over 180 degrees. These are the things that you really need to have in your head. This is your, like, what you always need to be knowing, that these things are equivalences. Now we're going to do the same thing. In this case, they're asking, we have minus 3 over 13 pi. We need to know is equal to how many degrees. We do not have the value of degrees of this one, but we do know that, well, this is radians, right? We know that 1 radian is equal to 180 degrees over pi. You need to put, in this case, in the root 3, always the radian is over another radian. In this case, it's radian, and to the other side is degrees and degrees. Now we're going to do again the multiplication and the division. Remember, the multiplication is in diagonal, and the division is over the value above you are. Now we do this multiplication. Minus 3, in this case pi, is going to be multiplying 180 degrees over pi. If I just use again my scientific calculator, it's here, minus 3 pi over 13 times 180 over pi. It is going to give us the value of minus 41.538 and 4 degrees. This is the answer. But we need to pay attention to this thing. They ask us to be rounding our answer to the nearest hundred. Remember, the first value is a tenth. The next one is the hundredth, and the third one is the thousand. But they're asking to be running to this one, so only have two decimals. As we have two decimals, we need to know if the third decimal is, in this case the 8, is above 5. If it is above 5, we need to change the value of this one. In this case, it's going to transform from 3 to 4. So the correct answer is going to be 41.54 degrees. As you can see, this is the answer here. And remember, we have the negative because it starts with a negative, so it's going to be a negative in here. The negative. Now, a favorite of you all. Sketching an angle in a standard position. Remember, in this case, we need to remember that this whole value half a turn is going to be equal to pi. I'm going to be writing here half a turn equals to pi. In this case, they are asking us to be dividing pi in 6 times. Pi is divided in 6 parts. So what we can do is to be dividing these in 6 parts. We begin in the middle, right? In this case we have 1 and 2. Now we need to divide this half in 3. We have this one, we have this one, and we have this one. So how many parts do we have divided the half? In 1, 2, 3, 4, 5, and 6. Remember, we need to be, if the angle is going this way, it's going to be positive. In this case, this is a positive angle. But if this were a minus sign, I'm going to be putting that in red. If this were a minus sign, for example, minus pi over 6, if it is going to the other side, it is negative. So if it is negative, we were not counting this way. We were going to be counting, for example, 1, because they were here, and 2 and 3, and 4 and 5 and 6. Remember, if these were negative, we would be counting this way. In this part, remember, they're asking to be solving 1/6 of pi. They're asking to be only coloring this whole part, only 1/6 of a pi. Half a turn, in this case, will be 6/6 of pi. Why? Because 6/6 equals 1, and this will be 1 pi, so it is half a turn. So half a circle. They're asking only 1/6, so we're only going to be coloring one part. That's why the angle is going to be marked this part, this whole part. I'm going to be putting that in blue so it can be more specific. This is the value. That's why you put your value here. Now we're going to the next problem. They're asking for a reference angle. A reference angle in a whole circle, we have this line that is going to be divided the circle in 180 degrees. A reference angle, for example, if we have an angle in this part, this is our angle. I'm going to be putting the symbol here. This is our angle number 1. The reference angle is going to be the nearest or the smallest angle in order to be reaching this line. So this angle, this one is the reference. In order to be solving this, we need to be adding sorry, we need to be adding half a turn until the angle is less than 180 degrees or pi radians. This is how you're going to be solving for the reference angle. In this case, they're giving us the references. No, not the reference. The angle is minus 4 pi over 3. I need to be adding something to this. Is less than this 180 or pi radian and bigger than 0. In this case, as it is negative, a negative angle is less than 0. So we need to be adding half a turn each time until we reach this condition. Less than 180 but bigger than 0. We're going to be adding half a turn. Half a turn is how much? Half a turn is going to be, we're going to be adding 180 degrees or pi radians depending on what they are giving us. In this case, they are giving pi, so we're going to be adding pi until we meet that condition. We're going to be adding half a turn to this one, so it's going to be minus 4/3 of pi. We're going to be adding a pi. Okay, this is how much we're going to be finding that out. 1. We can define it as a number over a number. In this case, look, a number over a number, right? They need to be the same number. So in order to be adding a third, we need to put the value of 1 because this one is a 1. Are we putting that in red? This is a 1. We need to put this 1 in order of 3 in order to be adding this without problem. So which number divided over 3 in order to match this one? This denominator is going to give us 1. It's going to be 3. So we can write this as minus 4 over 3 plus 3 over 3. Remember pi pi is going to be how much? Minus 4 plus 3 is going to give us minus 1. Minus 1, and the denominator, remember, it stays the same. Okay? This value is still a negative number. Remember, we need to be finding this condition. Less than 180 or pi radian or bigger than 0. Negative, in this case this is negative, is still less than 0. So we need to add another pi, another half a turn. Minus 1 over third pi. We're going to be adding again 3 over 3 pi. You remember why 3 over 3? Because this whole thing equals 1 pi. What did I say before? We're going to be adding 180 degrees or 1 pi each turn. So again, minus 1 plus 3 is going to give us 2 thirds. Thirds, why? Because the denominator stays the same. 2 thirds of pi. Okay? Now, this is going to be a little thing you need to know. This is a half a circle. We need that a pi is going to, meaning half a turn. Remember, half a turn is a pi. Pi or 180 degrees, half a turn, half a circle. Now this half a circle we need to divide it by 3. Why? Because they are asking us to be dividing by 3. Now the angle is 2 thirds, so it is going to be this one and this one, meaning that the angle that they are giving us is this one. You remember what did I say about the reference? The reference is the smallest angle between the angle and half a line. So they're giving us this angle, right? This is 2 thirds of a pi. So which is the value of this one? This is going to be the reference. So to find the reference is going to be, I'm going to be writing in the reference is going to be a pi, meaning the whole piece, the whole half a circle minus 2 thirds, that is going to be the ones that we found, is going to be, if we made that operation, remember 1 again is going to be 3 over 3 pi minus 2 thirds of pi. The reference is going to be 3 minus 2, 1. The denominator stays the same, 1 third of pi. This one. This is the answer to this problem. Now, another one. Again, we're using radians, and we're going to be solving. In this case, remember, in this case, 1 pi is going to be, in order to have, well, 41 over 12 pi's is bigger or less than pi. How will we know this? Because pi would be, if we put it in terms of 12, remember it's going to be another number that divided over 12 is going to be 1. 1. It's going to be 12. So is 41 over 12 pi is less than 12 over 12 pi? The answer is no. It is not less, it is not smaller, so we need to be subtracting. Why? Because remember what did I say? We need to add or subtract half a turn until the angle is less than 100 degrees or pi and bigger than 0. So in this case it is not less than pi. So we need to be subtracting. So this is going to be really easy. Subtract, we need to subtract this half a turn each time. So we need to subtract a pi. Remember, 1 pi is going to be equivalent in terms of 12 as 12 over 12 pi. So 12 it stays the same, 12, but 41 minus 12 is 29. 29 pi. 29 is less than 12? No, so we need to be subtracting again another half a turn, another 1 pi, another 12 over 12 pi. In this case is 29 minus 12 is 17. Remember, 29 minus 12, 17. The denominator, I'm going to write there, denominator stays the same. So 17 is less than 12? No. So we need to be subtracting another one, another value of pi, of 1 pi. So 12 over 12. Remember, we're subtracting 1 pi each time. This is going to be how many? 17 minus 12 is 5, right? And the 12 stays the same, the denominator stays the same. We compare, is this part bigger, is less than this one? Yes, is smaller than 12 over 12 pi. So we know this is a value. Now we need to know if it is bigger or less than half a circle. Remember, we can put this as 90 degrees. 90 degrees will be 6 twelfths of pi or 1 half or pi. Why? Because this part will be pi, this part will be 0. So 0, the half of a circle is going to be a half of a pi. This part is going to be a pi. 6 twelfths, this will be 6 twelfths. 5 twelfths is going to be a little less than that, right? It's going to be 5 over 10 twelfths. Now, which angle is bigger? This one or this one? Which one? Exactly, this part. So we have already found our value of the reference angle. 5 twelfths of a radian. 5 twelfths of a radian. Yes. Now the next one. Another reference angle. This is going to be a little, I'm going to be solving this a little faster, so you know how to solve this. We need to be doing 12 over 9 pi. Is it bigger than 1 pi? I'm going to be writing this. 1 pi will be 9 over 9 pi. 10 is bigger than 9? Yes, so we need to be subtracting, in this case, how much? The value of a pi. So we're going to be subtracting 9 over pi, because remember this is the same as 1 over pi. So the value is going to be how much? 9 minus 1? 1 over 9. What? Pi. Is 1 less than 9? Yes. So we draw our circle. Now this is 0 again. Remember this is the half of a pi because the half a circle is a pi. Half a circle in this case, if this will be 9 over 9 pi and this 0, the half of 9, this will be like 4.5 over 9 pi, right? So 1 is less than 4.5. Yes, so the angle would be like this part, right? So which angle is bigger? This one or this one? This one, right? So the value of this one is 1 over 9 pi. So we know that as it is the smaller one, this is the correct answer. This is the reference angle. Now, I'm going to be finding coterminals. Another circle, because I know you love circles. A coterminal angle will be the same value of this angle, for example this one. Now, if we add another angle, another turn, for example, it will be 360, and then we add another one. This will be the same value, right? Yes, this angle. Why? Because it will stay in the same side, in the same direction, in the same position. So a coterminal angle is the same angle adding or subtracting a full turn 360 degrees or 2 pi's. This is going to be our value. The first angle they're giving us is minus 23 over 12 pi. But they are asking to be between 0 and 2 pi. 2 pi in terms of 12s will be, I'm going to be writing this one here. 2 pi will be, in order to be adding, to have the same denominator of as 12s, will be 2 times the value of this one. So it's going to be 24. 24, right? So minus 23 plus 12, no, minus 23 minus 23 twelfths is bigger than 0. No. We need to find an angle that is between 0, it is asking us to be 0 and 2 pi, right? So it is not bigger, it is a negative, it is less smaller than 0. So we need to be adding how much? Half a turn. No, not half a turn, a full circle, 2 pi. But this 2 pi, we can represent 2 pi is 24 over 12, right? So minus 23 plus 24 is going to give us 1. And the 12s stay the same, the denominator is still the same. It's going to be 1/12 of a pi. Is this number between this one? Yes. 1 and 24. We can put it like 0 over 12 pi. So 1 is bigger than 0 and smaller than 24. Yes. So as you can see, this is our first value. Now for the next one, it's going to give us the coterminal angle is 1260 and yes, 60 degrees. So as it is above, because we're going to find this one and 360 degrees, they're asking us to be finding between these two numbers, right? So is this number bigger than this one? Yes, so we need to be subtracting and resting 360 degrees. How much is this? It's going to be 900. Is 900 bigger than this one? Yes, so we need to be subtracting another one. So it's going to be 550 degrees. This number is still bigger than the next one, right? So we need to be subtracting. Minus how much? 360. This is how much? 180 degrees. Is this number bigger or smaller than this one? Than 360? It stays within the range. So this is our number because it is smaller than 360 degrees and bigger than 0, right? So this one, solve B. Now to the next one, again. A number between 0 and 2 pi. Which is the number? Minus 3 pi. This is smaller than this one. Why? Because it is negative, so we need to be adding 2 pi, right? How much? 2 pi. How much is this one? Minus 1 pi. If we add this one, another 2 pi. Why? Because we compare this one. Is this within this range? No. So we need to add another term. We do this and they give us the value of 1 pi. Is this number between 0 and 2? Right. So the answer is 1 pi radians. Now we're going to be doing the same but with 90. Well, to number 2. The first angle they give us is 810 degrees. We need to find an angle that is bigger than 0 and smaller than 360. Is this one bigger than this one? Yes. So what do? We subtract. It's going to be 110 minus 360. It's going to be 450 degrees minus, we compare, right? It's bigger, right? So we need to be subtracting again. We subtract, how many is that? It's going to give us the value of 90. Is this number 90 bigger or smaller than this one? It stays in the range that we need, so it's going to be the answer, 90. And that is going to be all for this topic. Thank you. Good luck.